Everyone, welcome to another episode. So I have been lacking two questions behind this time as well. Pretty busy with work, but let's not waste any time and get on with the question. So you're given a positive integer and you need to output its complement number. The complement strategy is to flip the bits of its binary representation. So you're given 5, so five's binary representation is 101, and if you do a complement of it, like just toggle the bits, then it becomes 010, which is 2 in uh, 10 uh, in decimal system. So what we are going to do here is there are many ways to approach this question. If you use Python or Java, it's straightforward to just convert, just keep dividing this by 2, and whatever remainder you get, 1 or 0 or whatever, and you append it to a string, and then based you just iterate over that string, and based on the bit you just flip the bit, create a new string which is 010, and then you again iterate over it, and for for each digit, like uh, basically, in terms of when we want to convert it from binary to 10 base system, we basically are gonna take, so this we're gonna multiply this digit with 2 to the power of 0, this with 2 to the power of 1, and then this with 2 to the power of 2, and we just add it, right? So that is one way. Another way is, in the question they have given, you can assume no leading 0 bits are there, like obviously it, because they're giving a number, in a in decimal, 10 base system, and then it says that it's going to fit 32-bit integer. So what I'm going to do is, I'm going to use a different approach where, let's say if this is going to work or not. It's been a long time I've played with the bits. So yeah, so this is a number, right? Now this is the 3 bits, because 5, number 5 we can cover in 3 bits, but it says, the number is within the range of 32-bit, right? So a number can be given that has 32 bits. So what we're going to do is, like, let's say this bit is 0, this bit is 1, this bit is 2, right? So I'm just going to consider that all other 20, it should be 29 bits are going to be 0. So it's going to be something like this: 0 0 0 0 0, 29 of these, and then I have 101, right? So this is 5 basically. Now what I'm going to do, I'm going to have a for loop, and I'm going to have, so let's say I have a for loop from 1, basically from 0 to 31, and for each for loop, so this is going to be constant time, right? Because we know it's 32, so this is going to be O of 1. And now, what I'm going to do is, for each bit I'm going to do a left shift. So I'm going to take 1 and I'm going to do left shift of it. So let's say, how do we represent 1? We represent 1 with 0 0 1, right? This is 1. So what I'm going to do is, in our case, let's say my for loop comes to, um, for loop is 0, right? So I do one shift with 0, left shift with 0, that is going to give me 1. So now I do and with 5, so 101, and with 001, it gives me 1, right? So I know this bit is set in 5. I'm doing an and here, so this bit is set in 5. So what I can do in the same time, because this is 0 digit, I basically multiply it by 2 to the power of 0 star 1, right? And I'm gonna keep this in the record. Let's move on. So now when my for loop becomes 1, so I'm gonna do left shift of 1 by 1, so that's gonna give me this representation. So I'm gonna do and with 5 again, which is be 010, right? In this case I get 000. That means this second bit is not set, so I'm gonna do 2 to the power 1 star 0 plus next time my for loop comes on to 2, so I'm going to left shift 1 by 2, right? So it's going to give me I have 5 here. I'm going to take AND with 1 0 0 because I shifted by 2, right? So this is 1 2, so it's going to give me 0 0 and 1. That means my this bit is set, right? So if it's gonna be like greater than 0, if AND of uh, after doing left shift on 1 and 5 is greater than 1, that means my this bit is set is greater than 0, then that means this bit is set, so I'm going to just multiply 1 with to the power of 2, right? So something like this. So this is giving me 5. Now the catch here is, because we need to take complement of it, what we are going to do in this case, we were considering when the bit is set, we were multiplying it with to to that power of digit. But because we need to take complement, what we are going to do when we get this check where and of 5, so 5 and left shift with I, 1 of I, so this is going to be I, our for loop. So if this condition gives me greater than 0, that means that bit is set. So in that case, I'm going to do, I need to do a complement, right? So I'm going to do 2 to the power of I star 0. Else I'm going to do 2 to the power of, so I'm going to add this to a value dot sum. So this sum will have our final answer. So in this case, sum plus would be equal to 2 to the power of 1, right? And then that's how we can finish this off in just of one for loop. And it I think this is the best bit of operation you can do. Otherwise you need to go over and use string, and that is more like extra space. Bits operations are pretty quick and doesn't use any memory. So let's look this question in code. I'm gonna try Java today. Let's see. So int complement is gonna be 0. To power is gonna be it's gonna be starting with 1. Yes. I will check. So 2 to the power starts with 1. Yeah, 1. 2 to the power 0 is 1. So we can start with that. So we're gonna do 4 and 8 to 0 and plus 2 and plus, and then I'm gonna do if complement num and one doing a bit shift on this is 0. So in that case we just need to sum, right, because we are considering that it's a 1. So we're going to do 1 star, sorry, it should be complement number that is equal to, yeah, that's it. So we're just gonna do that, and then after each iteration we just multiply it by 2. So in next case it becomes 2, and then 2 to the power 2, and then that way. So once this is done, we are gonna return, let's run this code and see. It should give me 2. Oh, so I guess I need this. So we do an AND first, bit AND, and then we write it down. So it's giving me a -1. Oh, my bad. I need to do it with the number, not with the complement number. So it's giving me -6 here. What could be the error? Let me check bitwise and in Java. Correct, that's how you do it, right? So let me do this. Oh, my bad. If it's oh yeah, in case of 0 it will just toggle the bits, and we don't need that. We don't need the extra bit, yeah, because what is happening is for 5 for 5 it's 101. So what I'm doing is I'm just running the loop from 32 till the end, so that's gonna make all the other 29 bits also 1, right? And then we add it, so that's where it gets wrong. Let me check. So I can just run the loop till the first bit. That's it. That being said, let me run this and see what do I get. Oh, my bad. It's in Java. Okay, so now we are gonna run position of the most significant set bit, yeah. Find the most significant okay, set bit number below. Yeah, so find the lowest set bit. Yeah, we can write our own code in the sense first set bit. if one left shift of I is set, then we return right, or we return bit of num is equals to -1. In that case, fsp is equals to -1, then we know none of the bit is set, then that means the number is 0, so I just written 1 in that case, because the number is guaranteed to fail. Okay, so given a positive integer, okay, so it will be a positive integer, and then what I'm gonna do is yeah, so I'm gonna run the loop till equal to fsp, and then let's see what do we get. So I think we should get let me print fsp. What is fsp here? fsp. I think this code runs, I'm not sure what the center is. Okay, according to it, the first bit set is, oh my bad. So if I do, yeah, I need to move, so in order to find the first set bit, yeah, I need to do that num and moving that first is greater than 0, right? If it's not, then that's not the first bit set, so it should give me 2 here. Awesome. So now it's giving me the answer right now what I want. Let's see. Awesome, it worked. So I hope you guys, the question was clear. What I'm doing is I'm trying the first set bit using the bit operation, and then I run the loop till that point, and I'm using everything in that. So this O of, it's gonna run till O of 32, which is like O of 1, right? So using bits, you're basically saving a lot of time. Hope this question was clear and interesting. If so, please subscribe to my channel and give me a thumbs up. Thanks everyone.